Hello and welcome back. This is lecture number 13 on volumes of revolution. Actually, most likely that we will break this lecture into lecture number 13 and number 14 because it is quite long and I would like to separate it into two parts. So in the first part I'm going to explain what is the volume of revolution, how to derive the formula, and in the second part we'll do a small practice exercise on that. So let's begin. So as you can see, you can recap from lecture number 12, we can use trapezium rule to answer to give an answer for the area under the curve. Similar thing can be used actually to find the volume of the 3D shape. So let's begin and let's see how it can be done. Let's imagine that you have some sort of function like that, and it is a vase or something that is obtained by rotating that function relative to x-axis. So I'm taking that function and I'm starting to rotate it relative to x-axis by 360 degrees. So that's roughly what I'm going to get. And this of course is becoming a 3D shape, which looks more like a Greek amphora or some sort of tube, even not an amphora because amphoras are usually closed at one side. So anyway, we have a 3D shape of very irregular volume and we want to find out the volume of this shape. How to do it? Well, you probably know the formula from the GCSE course that area of the circle is pi r squared. How is it applicable to us? Well, we can break the figure or the shape into small, very small cylinders, like we've done or similar to those stripes or strips we've done during the last lecture. So let's imagine that we have several of them, and very many of them in fact. So each of that piece of pancake will be a very small cylinder with roughly the same radius. Of course radius will be changing, but if the height of the cylinder is very small, so the radius we can say we will not be able to change like too much. So the volume of each cylinder will be calculated by the formula pi r squared times h, where h is the height of that cylinder. The h is very small, so you can say that at very many cylinders and very small h, you get something which is close to the area of the circle and then times a very small number. So there is ideally an infinite amount of such cylinders slash circles due to their tiny height. So now the question is what to do with them. Well, similar to integration when you find the area, if you add all of them, so you can say that this is volume 1, that one is volume 2, and so on, V2. So if you add them up, V1 plus V2 plus V3 and so on, you will get something which will be the volume of the whole 3D shape. So you will get the volume of everything. So the question is how to add them if we don't want to do it piece by piece or like to add infinite amount of circles. So to answer this question we first need to deal with radius. So usually if the radius was constant, it wouldn't be any problem just to add them all up. But the radius is changing here. So the question is, what is the radius? Well, the radius of each of them is exactly the value of the function. So you can say that Rn is f from certain x nth. And this is the key for the answer. Because in this case, by integrating the radiuses, by finding the definite integral, we can find the sum of all those radiuses like in the case of trapezium rule. So here we have r squared in the formula of area, so this is the square here. So therefore we need to square the whole function to get the squares of each radius. So therefore the formula will be integral of pi r squares. However, since pi can be taken outside, I can write it that it will be an integral, like pi times integral of those r squares. I'm not including h because h is tiny here. And r squared is f from x squared, so I can write it as pi integral of f from x squared dx, or I can rewrite it as an integral of y squared dx and then pi in front. And that's how you get the formula for the volume of revolution. Thank you for watching. This is it with part number 1. In part number 2, we're going to discuss the boundaries and then do a small exercise. See you soon in lecture 14.